Hey everyone, welcome to another Tutorial Tuesday. So in the last episode, I went over this like get index, are exceptions good, all this kind of stuff. And I got to thinking, and I even mentioned this in the previous video, that, well, what is a better way to solve this, right? So I'm actually going to kill all this stuff and probably some of these other things too. I think another way to solve this is with some C++ 17 magic. So that's what I want to talk about. And I'm just going to delete kind of all this old code that we had here because it doesn't matter. What I want is I want something that's going to get this index. And instead of throwing an exception, what can I do? Well, there's something called optional, standard optional. Now, this is something that I've actually worked with a bit in the past, long before C++ 11, because it's just a construct that I've seen in other game engines. I co-authored a book a while back called Game Coding Complete. So like if you just Google it, yeah, this is it. And all the way back, I think even in the first or second edition, which I had no direct part in, the Mike McShaffrey, who was the author of those books, had an optional class. It was very similar to this one, and we kept it sort of going forward, like here, right? In some of these, none of these are really great pictures. Here's a better picture of it. So it's still in this book. If you dig through and find the code or find the book, some of that old optional stuff is still there. If we were to do a 5th edition, we would remove it, of course, in favor of standard optional. Assuming that we end up going with C++ 11 type stuff, or in this case, C++ 17. So this is a C++ 17 thing. Standard optional basically says, under the covers, it's and if you're familiar with C#, there's a C# analog of nullable types. It's essentially, you can consider it like a nullable type. It maintains a state as to whether or not something was set or not. So that's a really kind of powerful thing, So in other words, this variable can have two states. It can either be set or not set, and you can query that. If it's set, it's just a value, and you can grab trivially. If it is not set, you can branch on that stuff. So in our case, what we want to do is we want to say standard optional of type size t, and that's it. So let's do a quick search. So standard optional, if we go here on CPP reference, we can kind of look it up and see what's here, C++ 17. And it has a really trivial API. It overloads like the assignment operator and stuff like that, and just various other operators so that you can, like some of these sort of operators here, so that you can generally mostly treat it like the variable that it's encapsulating. So down here, we have value, which is returns that contain value. We have has value, or if you just, operator bool, so if you just use it in a Boolean context, it will do it. I personally tend to use has value simply because I think it's more explicit what I'm doing. So has value is the, so you can just check for that. You can say value, return the value. You can say value or, return the value or another value if you want to default it to something. That's reasonable. And you can destroy the contained value through reset. It's under the covers. It's typically a union, so it occupies the exact same. Generally, it occupies this, a pretty small amount of space based on whatever you're trying to store. So it's a pretty straightforward thing to use. In our case, we're simply going to return. So one way I could do this, I could say, return standard optional bracket size t, default constructed. Like this is one way of doing it. I actually find this to be more readable, like just literally initialize our list here. This will do the right thing. It will default construct an optional. Otherwise, return index. And this should work because it will be able to cast this index in without any issues whatsoever. So there shouldn't be any issues, and I can return index here. And this might cause an issue. Actually, I don't know why I have this return here. Right, so this should just work. So here, again, I can't do like size t whatever. I would have to do standard optional size t. Normally in this case I would use an auto, but I'm doing this to be explicit for this, right? Index equals this get index. So if I do, like I said, it shouldn't have deleted everything. Let's go back here and create my vector, and I'll say standard vector of, you know, size, const expression, size t. Okay, num tests. And we'll do 1,000,000 again. 1,000,000 seems to be sort of the magic number for me. So k num tests, right? Oh, what am I doing? That's not what I want. I want size t, whatever. And then I'm going to say vec.reserve. This is what I get for thinking and talking at the same time. There we go. And so now what I want to do is I want to do for, you know, size t I equals 0, I is less than k num tests plus I. So we're just going to loop through this thing, and now we're going to do the same type of thing. So I'm going to do this, this guy. Standard optional index equals get index, right? And so this will construct my new standard optional, and life is good. So now I want to say vec.emplace back. So there's a bunch of things that I can do here. Like one thing that I could do is I could say if index index dot has value, emplace back, right? That's kind of the easiest thing to do. Hey, if this succeeded, then do this. This is often what we're doing, right? We're often saying, like, the inverse of this would be if I did some kind of like index is equal to, you know, standard numeric limits. I mentioned this last time, right? Like this is numeric. What am I doing? Size max, like boo, right? That's just lame. Whereas here, this is super good and readable and fine. Not really, it's relatively performant and so on. And then just for fun, so that I'm actually printing something out, I'll say, you know, vectors. I'll print out the vector size or something, right? Vec.size. No one wants to see 500,000 different things. Great. Okay, and oh, and it would also help if I actually did index dot value, right? That would help as well. So if I build this and I run it, I get, oh, and it would also help, of course, if I was too zealous. It would help if I actually seeded my random number generator. It's going to return 0 every time. There we go. That's much better. It's 498,908. That's, you know, that's what I would expect. It's somewhere around 500,000, right? So I can just run this a bunch of times. But you can see that I can now gate on this thing. You know, another thing that I could do is if maybe I want to fill them all, but I want to say, I do want to have some default thing. I could easily do vec.emplace back, index.value or, and now I say it's this value or it, you know, it's the indicated value or, you know, 0, right? Something like this. So I could just have like an easy, here, I'll do this, an easy default to 0. And it just sort of does this thing for me. And of course, this time it's going to give me 1,000,000 every time because it's going to fill it with, you know, several hundred, you know, 500,000 or whatever are going to be 0. So, I mean, that's kind of it, right? That's all that we've got here. Standard optional is super easy to use. I have not, in my own engine, switched over to C++17 because I'm not able to find a lot of good information about which consoles support what. Generally, I'm finding consoles supporting C++17 language features, but not library features. Anyway, I do use C++17 library features because I use the EASTL. And there's an EASTL optional, and so they have a bunch of this stuff already. So I'm using this in my own code base and everything, and it can really help in these types of situations where you just need some kind of thing, like some essentially nullable type, right? Something that's like, this could be set or not, but every value is useful. So now we don't have to abuse, you know, poor -1 or poor, you know, infinity anymore. We can actually say intentionally whether or not this thing was set. Cool. Well, if you have any questions or anything like that, please let me know. And thanks for watching. I'll see you next time.